When you take on the challenge of learning a new sport, say, mastering a tennis serve or flowing through a martial arts sequence, you're doing far more than just building muscle memory. You're literally reshaping your brain. Thanks to neuroplasticity, the brain's innate ability to change and adapt in response to experience, each session of practice rewires neural pathways, enhances connectivity, and sometimes even leads to structural growth in key areas of the brain. It's not just that the brain learns the movement changes the brain. MRI studies have provided compelling evidence of this process. In individuals learning complex motor skills, such as juggling, fencing, or taekwondo, researchers have observed measurable increases in gray matter density in areas related to motor control, coordination, and sensory integration. The cerebellum, which helps fine-tune movement and timing, often shows notable growth. So does the primary motor cortex, which is responsible for executing voluntary movement, and the premotor areas, which help with planning and sequencing actions. Even the basal ganglia, a group of structures involved in habit formation and skill automation, become more active and interconnected over time. What's especially fascinating is how quickly these changes begin to appear. Some studies using voxel-based morphometry, a method of analyzing structural MRI data, have shown brain remodeling within just a few weeks of consistent practice. In one well-known study, participants who learned to juggle demonstrated increased gray matter volume in the mid-temporal visual areas, regions associated with tracking moving objects, after only 3 months. When they stopped practicing, some of those gains diminished, suggesting that neuroplasticity is not just reactive but also dependent on continued use and reinforcement. Sports like tennis and martial arts offer a particularly rich canvas for neuroplastic change because they demand not only physical precision, but also high-level cognitive engagement. These are not purely repetitive activities. They involve decision-making, rhythm, timing, spatial awareness, and real-time problem-solving. In tennis, for example, players must constantly anticipate ball trajectory, adjust their positioning, and select the appropriate stroke, all within fractions of a second. Martial arts require balance, directional movement, and moment-to-moment recalibration based on an opponent's shifting energy. These demands activate networks that span the entire brain, from visual and motor cortices to areas linked with executive function, like the prefrontal cortex. Moreover, learning a new sport enhances interhemispheric communication. Functional MRI scans reveal increased connectivity between the left and right hemispheres of the brain, especially in activities that require bilateral coordination, such as striking with both sides of the body or using footwork patterns that alternate between dominant and non-dominant limbs. This kind of brain integration improves not just athletic skill, but also general mental flexibility, reaction time, and even emotional regulation. Importantly, these effects are not limited to young or elite athletes. Older adults who engage in new forms of physical learning also show improvements in brain structure and function. In fact, exercise-based neuroplasticity is one of the few non-pharmaceutical strategies proven to delay cognitive decline. Learning new motor skills stimulates hippocampal activity, critical for memory formation, and has been shown to increase the volume of this region even in aging populations. This means that taking up a new sport isn't just fun or physically beneficial, it's an act of brain preservation and cognitive enhancement. All of this underscores a powerful message. Your brain thrives on challenge, especially when movement and learning are involved. Unlike rote exercise, which can become automatic and cognitively passive, learning a sport keeps the brain engaged, adaptable, and growing. It stretches attention, requires problem-solving, and creates opportunities for both failure and feedback, essential ingredients for long-term neural development. In a way, every new skill acquired on the court, mat, or field is a kind of cognitive upgrade. Your brain becomes more efficient, more resilient, and more connected. And the more diverse and complex the challenge, the richer the neuroplastic payoff. So whether you're picking up a racket for the first time or learning to throw a punch with precision, you're doing something profound, not just for your body, but for the very architecture of your brain.